All right, so we left off where we're going to find the cosine of theta. So the cosine of theta, as you all know, is the x-coordinate of the point. So that's going to be negative 0.276. Sine of theta, as you know, is the y-coordinate. So that's going to be 0.961. Then they ask us to find cosine of negative theta. Now remember, cosine of negative theta equals cosine of positive theta. So we already found that the cosine of positive theta was negative 0.276. So the cosine of negative theta must also be negative 0.276. They then ask us to find sine of negative theta, and we come back over here to the rule we established in the previous video. Sine theta is the opposite of sine of negative theta. So here's sine of positive theta, and it is the opposite. Sine of negative theta is the opposite, therefore negative 0.961. All right? Now they're asking us to do cosine of theta plus pi. Well, here's cosine of theta. If we add pi, that means we add 180 degrees, which means we are going to move this angle that is in quadrant 2. If I add 90, I move here. I add 90 again, I move here. In other words, just directly across on the unit circle. And they would like us to find the cosine, so that's going to be positive 0.276. They also want us to find sine of theta minus pi. So this time we start here at theta. Since we're subtracting, we're going to go clockwise. So from here, quadrant 2 into quadrant 1 is minus 90 degrees, or minus pi over 2. So here we end up here in quadrant 4, which is minus pi, or minus 180 degrees. In other words, we end up at the same spot. Doesn't matter if you go 180 in the positive direction or 180 in the negative direction. Regardless, we still get to the same spot. We make half a revolution. They want us to find sine y-coordinate, therefore negative 0.961. It makes sense that the sine value is negative because we are in quadrant 4 where y values are negative. If you'd like to generalize kind of a rule from there, we have it here. If you add or subtract pi, that is to say 180 degrees, then change the sign, S-I-G-N, of the cosine and sine values. And if you notice, that's really all we did. Cosine of regular theta was negative 0.276. Cosine of theta plus pi, positive 0.276. Similarly, sine of positive theta, 0.961. Sine of theta minus pi, negative 0.961. Now they're asking us sine of theta plus pi over 2. If we step back and think about this for a second, we've started here in Q2, and they want us to add pi over 2. In other words, they want us to add 90 degrees. So that means since we're adding, we want to go counterclockwise. So we're going to end up here in quadrant number 3. Now, how do I know these coordinates? Well, what I did is I drew a little triangle here, because remember the unit circle is just made up of right triangles. And I noticed that this side right here, this small side of this triangle, seems to be really similar to the small side of this triangle that is in quadrant 3. The big side of the triangle in quadrant 2, which is the original theta, seems really similar to the big side of the triangle in quadrant 3. So what are we seeing? We're seeing, well, what used to be x is now y. What used to be x is now y. What used to be y is now x. So in other words, the coordinates have switched. And of course, both of these here in Q3 are negative because, as we know, the x and y coordinates are negative in quadrant 3. Hence, they ask us for sine of theta plus pi over 2. Here's theta, add pi over 2 we get here. They want us to get the sine, which as we know is the y-coordinate, so it'll be negative 0.276. Now, next they want us to do cosine of theta minus pi over 2. Here's theta, And remember, all we do to do minus is we flip back here. Remember, we go clockwise when we subtract angles, when we have negative angles. So, similarly, draw in my right triangle here. Short side looks really similar to this short side. So what used to be x looks like it's the new y. So what used to be x, 0.276, negative 0.276 because we're in quadrant 2, now becomes the y coordinate, 0.276. The reason this is positive, folks, is because we are in quadrant 1 and the y coordinate is positive in quadrant 1. Notice that what used to be the y coordinate right here is now the x coordinate. This long side is now this long side. So what used to be y is now x. And again, the x coordinate is positive because we are in quadrant number 1. Hence, cosine of theta minus pi over 2, that's right here. Remember, here's theta. We are going clockwise because we're subtracting. In other words, we have a negative pi over 2. They want us to find the cosine, hence 0.961 because that is the x coordinate. Remember, cosine is x. If you want to generalize a rule, you could write if you add or subtract pi over 2, that is to say 90 degrees, then switch the sine, S-I-N-E, and cosine, and determine the sine, S-I-G-N, from the quadrant. All right, and let's finish up here. We have cosine, next one, of pi minus theta, and sine of pi minus theta. A lot of people think that what we have going on here is the same as this. If you notice, if you look closely, they're not. This one, theta minus pi. Here, pi minus theta. It's not the same thing. So I need to rewrite this because I cannot use this rule, right? Remember, this rule said if you add or subtract pi. But I am not adding or subtracting pi here. Rather, I'm subtracting the theta. So I'm going to rewrite this, pi minus theta, as negative theta plus pi. So now, this rule is nicely applicable because the rule says if you add or subtract pi, then we change the sign. Now we are adding pi. So I'm going to say cosine of negative theta plus pi. Cosine of negative theta is negative 0.276. And remember, cosine of negative theta equals cosine of regular theta. And now I'm going to add pi, which means change the sign, make the value positive. Similarly, sine of theta minus pi, rewrite that as sine of negative theta plus pi. Sine of negative theta is negative 0.961. Add pi becomes positive 0.961. If you want to see that graphically, you can come over here. We start here, sine, then we become negative theta, that's down here. And then we add 180, so we come up here. Hence, both sine and cosine are positive because we are in quadrant 1. And truly, the last two, folks, sine of theta plus 3 pi over 2 and cosine of theta minus 3 pi over 2. Remember, 3 pi over 2 is just another way of saying 270 degrees. So here's theta. I'm adding 3 pi over 2. So that means what? Well, I add pi over 2, I get to this. I add pi over 2 again, I get to this. I add pi over 2 again, I get to this in quadrant 1. I add 90 degrees, I'm here. Add 90 degrees again, I'm here. So I've added a total of 180 from where I started. And then I add 90 again, I'm here. So I've added a total of 90 plus 90 plus 90. 90 here, 90 here, 90 here, for a total of 270. And they want the sine, so they want the y value, so 0.276. And the last one, cosine of theta minus 3 pi over 2. Keyword here is minus, so we start here and we go clockwise. We start here, we go clockwise, we subtract 90 again, subtract 90 again. We subtract pi over 2, subtract pi over 2 again, subtract pi over 2 again. We get here, they want the cosine, so we get negative 0.961. Let me zoom out so you can see everything. And that's the video.